Okay. A person takes 12 steps forward, another 6 steps forward, and then 6 steps backwards. A, they want us to draw a vector diagram for this motion using a scale of 1 centimeter per step. So, I don't think I have a ruler on here, but on your paper, you'd want to get a ruler and make sure that every step is going to be 1 centimeter. Okay. So, 12 steps forward. We'll say up is forward, which is the positive direction. We want 12 steps forward, just like that. And we want this displacement to be, you're going to measure it out. It's going to be 12 steps in the forward direction, which will also be the same as 12 centimeters. Okay. Forward. Okay. Since 1 centimeter is 1 step, and the way we convert that, if we're using our good old method of converting, is since we know 1 centimeter is 1 step, okay, we want to get rid of the steps and get centimeters. So we're going to leave centimeters up here and steps down here. And we cancel out the steps, and this gives us 12 centimeters forward. Okay. Right. So there's another example as to where this really shines, okay? We take another 4 steps forward. Oh no, I didn't plan this properly, because now we're out of space. So maybe I'll make this one a little shorter. Okay. We make another 4 steps forward. So say this is delta D1, this is delta D2. 4 steps forward, and this is 4 centimeters forward. Okay, and then 6 steps backwards. 6 steps backwards would cover more than the 4 steps, so we'll say it's back here now. This is delta D3 is equals to 6 steps back. All right, BK for back, and that is the same as 6 centimeters back. Okay, there we go. So there's our vector diagram. On to part B now. Part B, verify your results by physically walking out this motion. How close is your measured result to your predicted displacement? So it doesn't actually tell us to find the displacement, but you know what? We'll find the displacement here in the second question. So our total displacement is equals to the first displacement plus the second displacement plus the third displacement. The first displacement is 12 centimeters forward. Plus our second displacement, which is 4 centimeters forward, plus 6 centimeters backwards. Okay, and we'll say forwards. Forwards is our positive direction in this case. Okay. All right. So now let's make these all scalars and do our good old sign convention here. So it's going to be everything forward is going to be positive and the 6 is going to be negative. And if any of this confuses you, we covered a lot of it in the previous video. So go back one video and you'll see a more detailed explanation with this method. We did about 3 or 4 questions. All right. we went over the ways to convert it from vectors to scalars and why we use the positives and negatives and everything else. Okay, so if we plug this into our calculator, we would get 10 centimeters, and 10 centimeters is in the positive direction, so it is 10 centimeters forward. Okay, there's our total displacement. Box off our answer. There we are. And if you want, you can actually do B physically in real life. Walk out a few steps. I know your step isn't 1 centimeter. That's just what it is on the paper. So it should be about 10 steps from where you started forward. Okay?